So again, we have two solutions, one solution, and two non-reals. So over in that for example, when the quadratic does not cross the x-axis, that is the case where you are going to get i's. That is the case where you are going to get i's. So to graph a quadratic inequality, we're going to graph the related function exactly as we were graphing it before. However, now we're going to pick a point not on the parabola and shade accordingly. So we're going to pick a point not on the parabola and just shade accordingly. So just like when we graphed linears and absolute values, you graphed the line or the v first, then you picked a point not on the line or v and shaded with that in mind. We're going to do the same thing for quadratic inequalities. So we're going to start by graphing that quadratic function and treating the inequality as if it were an equal sign. So you have a quadratic in standard form. It's y equals x squared plus 2x plus 1. So I'm going to find my vertex. So my vertex is at -1. I'm then going to take -1 and plug that in. So I have 1 squared plus 2 times -1 plus 1. So that gives me 0. And then you're going to make your table of values. So you're going to plot your y-intercept, which is at 0, 1. We're given that in my graph. That also means I have a point at -2, +1. And again, we could always either just plug in 1, or if you did your table, then it went 0, -1, 0, 1. And then doing your ya plus k, it would go 0, 1, and then 4. So 1, 4. And 2 is actually at 9, which would be off my screen. Now, this inequality is greater than, but not equal to. So you can see that up here. So if the inequality is greater than but not equal to, that means that my graph of my quadratic is dashed. And then we're going to test a point not on the graph. So I'm going to pick the test point, 0, 0. So you plug 0 in. You get 0 greater than 0 squared plus 2 times 0 plus 1. And you get 0 is greater than 1. Is 0 greater than 1? No. So my test point is false. So that means I shade on the opposite of my test point. So since my test point was outside the quadratic, that tells me I'm going to shade inside. Good? Okay, so once again, now we have a quadratic that is open down. So same idea. We are going to find our vertex. Find our k value for our vertex. And then we know our y-intercept. It's up here, so that's the point 0.05. So we can always plot that. Now you just have to be careful because that's 3/4 units to the left. So you're not going to have the point at 1.5. It's at the point 1.5 because you have to move 3/4 units to the right to get its counterpoint. So it's kind of like at 1.55. And again, you could do your x minus h, ya plus k. You can also just always plug in numbers. So again, if you don't like fractions because this is going to force you to subtract a fraction from all of them, you could plug in the number 2. So you could say -2 times 2 squared plus 3 times 2 plus 5. Just the problem with plugging in something like the number 2 is that you don't get your symmetric point. So if the table and all of that's still messing you up, you can plug in numbers that you just have to know that when you plug them in, there's no symmetry to them. So like you'd get the nice point 2, 3, but that doesn't give you the nice point on the other side. Does that make sense? So like you're not following your symmetry if you just plug in random numbers. So like if I plugged in -1, I get 0. But I can see over here, I don't get 0 when I plug in -1. My graph would be solid and open down. And again, you're going to pick your test point. So maybe this time I pick the point inside the quadratic of 0, 0. So I get 0 is less than or equal to 5. In this case, that's true. So I say shade inside my quadratic. And my quadratic is solid, meaning points on the quadratic would also make that true. So in the last example, you couldn't pick any points on your function because it was dashed. Now that my function is solid, I can pick points from the graph to be true as well. So when graphing quadratic inequalities in one variable, we're going to talk a little bit now about how the graph is on the x-axis and finding them. So that's graphing quadratic inequalities with a y value. Now we're looking at graphing quadratic inequalities for their solution value. So if they're less than 0, if they're greater than 0. So now this is one variable. That was 2 variables. This is 1. because now we're talking about when my y value is 0. If the y value is 0, then my solution is only going to come from the line. If my y value is 0, then my solutions are only coming from the x-axis line. So in case 1, if my quadratic inequality is less than 0, then my solutions are going to come from the inside of the quadratic. But again, I'm only shading on the line. So the red line is the solutions. If my quadratic inequality is greater than 0, then the solutions are coming outside and on the x-axis. If the y value is equal to, then it includes the roots from the quadratic. So if it's greater than or equal to, it'll include the roots from the quadratic. And if is it just a greater than, then the roots of the quadratic are not included. So that's what the last statement right here is saying. So the easiest way to truly understand that is to graph it. So we have x squared plus 2x minus 8 greater than 0. So you can look at that quadratic and say, okay, I have x squared plus 2x minus 8. So I know what that looks like as a graphed quadratic. It's going to be factorable, right? Can you factor x squared plus 2x minus 8? Yes. Because now we care about the roots. So what I'm going to do is factor that to find my roots. So that's the same as x times x. And then you need two numbers that multiply to negative 8 but add to 2. So that means my larger factor of 8 is positive, and my smaller factor of 8 is negative. So you're going to have a positive 4 and a negative 2. So that means the roots of this are at x equals 2 and x equals negative 4. The roots of my graph are at 2 and negative 4. So my shading is either going to be between my roots or outside my roots. And you can look at our cases that we talked about. Now, this graph, its vertex is going to be directly in between those two roots. So your h value is negative b divided by 2a. So my vertex or my axis of symmetry is at negative 1. And then you could plug negative 1 back in. So you'd get 1 minus 2 minus 8. So you get negative 10 plus 1 or negative 9. So again, we don't really care so much what the quadratic looks like because we're caring about the solutions of the quadratic. Because a is greater than 0, my graph opens up. And then we also know the x values are less than 0. So you could pick x equals 0. And if you plug in 0, you get 0 squared plus 0 minus 8 is less than 0. So you get negative 8 is less than 0. Is negative 8 less than 0? Yes. So since my test point was between those graphs, that's where my solution is. So your homework on those next pages, do the graphs that have the y's. So you're doing 13 to 18. You're doing 13 to 18 for tomorrow.